We're starting with a presentation from Graeme and Florence. Both are from Europe, been focusing lately on their efforts towards circularity of glass. We had yesterday a wonderful workshop, a wonderful production. And well, without further ado, I'll let them take the stage and talk to you more about circularity of glass.
Thank you. Thank you very much, Sophie. Let's jump straight in. I'm Graeme DeBrincat from Europe, as Sophie's already said.
I'm Florence Wu.
I'm a facade engineer. Florence is in our materials science team. So hopefully we can talk a little bit about where we see the really important next steps in glass recovery, glass recycling, glass reuse. So I wanted to start with this image, a place that's not too far from where I grew up, on the beautiful Stradbroke Island in Queensland, Australia. And this is a high-quality silica sand mine, very similar to many around the world, where our raw materials for the material that we all very much love, that's why we're in this room together, and this is where those materials come from. I wanted to start like this because I think sometimes we forget, as much as we love our material, about where those materials come from. This mine has been recently closed, and it's because of the environmental impact on this very beautiful natural environment. Also, a random float glass plant in the world. They often look like this. We know that it's carbon-intensive process. And we know, because we've been listening all day to wonderful presentations about how important it is to decarbonize the glass industry. So we're not going to spend any time talking about the reasons why we should decarbonize the glass industry, because if we don't know already, then I don't think we've been at this conference. So this is one of my favorite buildings in England, and this is the Great East Window at York Minster. These windows have been in position for over 600 years. 1408. So glass is a material. Why do we love it so much? It's durable. It has a great durability, long-term use, infinitely recyclable. But of course, we assemble these items into double glazed units, insulating glass units, such as this cathedral to business, perhaps, in the City of London, the Lloyd's building. This is maybe then, if York Minster is my favourite, this must be my second favourite building. I've had a great pleasure of working with this building, and Arup have been involved with this building since its design back in the 1970s. And very privileged to say that we're still working with the client, with the Lloyd's insurance company, to think about the future of this building. In the atrium here, 14-storey internal space. It is very much cathedral-like inside that building, a wonderful space. That is fully double glazed from 1986, and those units are at the end of their service life. So to be trusted by our client to talk about how do we find the next use for these materials is a really important piece of work that we're doing. We haven't solved it yet, but we know that we need to make change to this building to make its performance viable for the future. So we can think about reuse, remanufacture, recycling of those materials. And all of those are on the table. We've got to find the right one for this building. An image from the Arup website. And this is a collection of tall buildings across the world, all put into one skyline. A couple of smaller iconic buildings, such as the Sydney Opera House, and Lloyd's building is tucked in there somewhere. So I feel very privileged to work for a company that's designed such iconic landmark buildings across the globe. But when I see this image, I start to think of the extent of the challenge that's ahead of us. All of these buildings are on their approach to end of service life of double glazed and triple glazed units. So there's a huge responsibility for us to do something. We know about the carbon benefits, we know about raw material use, but there's this demand as well. There's a demand from the glass industry for more cullet, increased recycled content. There's a demand from these buildings coming to their end of life. So we've been thinking very much about the network. How can we create this? How can we create this network to make change? And I think that's the essence of what we want to do at our workshop yesterday. And again, the message today. This is a huge opportunity to make change. This is a kind of linear process, a bit curvy at the end, but a linear process nonetheless. I've made a little note of the existing cullet return schemes. That's very good. We've talked about this morning internal cullets and pre-consumer cullets, etc. I think everyone in this chain, and there's a bunch of us probably in this sort of area here today, has a responsibility to try and do this. How do we change that into a circular economy approach? And our thoughts are that there's two huge opportunities, and we've called them specialist facade dismantler, and we've called them glass recoverer. And that is the first step for us to respond to this demand and supply opportunity. So those two new roles are ones that we believe, well, in fact, we know they're already being filled in the industry. And that's very exciting because we've done a number of projects where we've kind of used this approach, perhaps in an informal way. For specialist facade dismantlers, what a huge opportunity for existing facade contractors. We're already seeing that. We're talking to a lot of the facade contractors in this space who understand this opportunity. So again, I just want to highlight that opportunity. These contractors know and understand facades. Who better to take them apart, prepare them ready for reuse and recovery? And of course, the glass recoverer role. Again, we see this as a huge opportunity for existing glass processes. This used to be called glass processing days. So I'm hoping that this is the right place to inspire and to really push this opportunity. These are our materials. People in this room have designed those wonderful buildings. People in this room have manufactured the materials so they understand them. Why shouldn't we look after them, find reuse and recycling opportunities? I think this has been something we've talked about again in different arrangements during the day. We know that all of that glass on all of those buildings is never going to come back to flat glass. And of course, there's a huge demand, there's good carbon reasons to do so, and that's got to be our aim. After we aim to reuse as well. So, the hierarchy of circular economy, of course, but let's think about cullet, about that demand. So there must be flows of material into each of these places. And that, to me, is all about being prepared to audit the building, understand the materials very early on, and then make a plan for those materials in their second use. And as I said, if we can get that right, I think there's then opportunities to move towards reuse. I think we should be doing them in parallel. Opportunities will come along for reuse. But just to finish on a couple of projects, mentioned the Lloyd's building already, and why I think our client is trusting us to perhaps do it again is because we've already recycled glass from the Lloyd's building back 2010. So we've been thinking and doing this for a little while. We got 100 tons back to Saint-Gobain glass in that instance, and it was remelted. There was also some reuse of materials as coffee tables, which was quite interesting. More recently, we've just finished the Burrell collection in Glasgow, and again there we specified in the demolition contract the glass shall be recovered and recycled at its highest use. So we need that network so that it can respond to those kind of specifications. We got only about 16 tons back, and we learned a lot of lessons. We were reminded how hard it is to recycle laminated glass, very large panes for health and safety, etc. So perhaps we didn't get as much back to the float line, but we learnt a lot. And a more recent project again, also in Scotland, is the Resident Hotel. So that's all I want to say, just as a setup. I think it's really important that we move in this direction, and Florence is going to tell us how to do that.
Thank you, Graeme. I didn't realise how red this was going to be, but there you go. That is our colour. So as a materials engineer, I have a favourite material, do I? That's basically the question I always get asked. And the answer to that, maybe at GPD, yes, but normally, no. I like a lot of other materials too. And I just want to highlight this, that when we're talking about glass recovery, we also need to talk about material recovery. And it's surprising that these aren't actually conflicting goals. Everyone is trying to move in the same direction, and it actually helps each other as we move on to this. So when we look at complex composite material, I'm going to refer to some low barrier glass assemblies as well as high barrier glass assemblies. And when I talk about low barrier glass assemblies, I'm talking about single glazed unit, monolithic glass. Why aren't those going into the cullet already? And then we move on to a double glazed unit. No, it's not. Gone into a double glazed unit. And again, these are low barrier glass assemblies that can be recycled today. We don't talk about the spacers and sealants, but those also have recovery routes too, and we're going to touch upon those in the next couple of slides. But we also add complexity as we get into modern day glass assemblies, and I'm going to class these as high barrier glass assemblies. So these are ones that we're not seeing coming down from the buildings today, but in the next 5, 10, 20 years, we will be seeing post-applied films and laminates, and how are we going to address that now? So looking at what we're doing today, so looking at the projects that we've worked on before, we found out that using bins and cullet bags aren't actually going to be that successful because people use them as bins. So you're adding your waste into there, adding contaminants, and we found that the best approach was actually using stillages. So how do we make it into a cost-effective way for the first couple of projects? Mechanical methods. Low skill, but relatively high yield. But we still need to do more because we are finding there's glass still on the edge sills. We're not addressing the sealants and the spacer bars. And also, we're removing that option of reuse at the end. So we find this as an industry collaboration opportunity to find DGU separation, and we want your help to do so. So when we look at DGUs, we're looking at these 5 main components, and there are different opportunities for each of these. And there's already recycling routes for some of them, such as glass, the frame, maybe even the space bar, as long as we can separate them cleanly. So removing that chaos, removing the crushing method, but separating them cleanly and as long as possible so that we can actually return each material to its own industry. Just a bit of fun. This is how we did it back in our garages at home. So using very simple tools, a tire groover, a hot air gun, and a paint scraper. If we can do this, surely industry can do better. Oh, that's the wrong one. So there's lots of opportunities out there. And as we move across into more complex glass assemblies, we see that there's a film removal, laminated glass, and even PV and switchables. All of these need separation methods in all of these opportunities. So the biggest opportunity that we see at current, and the one that has the most complexity and the most urgency, is laminated glass. And the reasons for that is because there's an increase in both supply and demand. And what I mean by supply is that as we get these window assemblies out of the buildings, there's going to be more laminated coming back down, but we're not going to be able to recycle them now. And then also there's a demand for it. There's an increase in using laminated glass, both because of performance reasons as well as safety. So when we look at laminated assemblies, mostly looking at the 2 main interlayers, PVB and EVA. Both of these are highly valuable materials, both in financial and in carbon costs. So what are we going to do about these materials? Because they still need a recycling route. We've seen that glass manufacturers do have options to do this, but they're not being able to have the highest level of recycling, both for the glass and for the interlayer suppliers. So we need methods to separate these cleanly as possible. So just as an example of what we have currently, we have the crush and combust. So you can put it into the furnaces already, but that's going to change the processing temperatures and how you do that. So that's not ideal. And also, if you're just crushing it, you're also having PVB contaminants with the glass, and then glass is a contaminant for the PVB, and they can't use that material either. There's other research methods, such as cryogenic and temperature and heat, But again, that's affecting the interlayer and the properties of that. So that's not going to be able to be used for high-level reuse recycling. So there has to be another way. So we did the workshop yesterday, and I wanted to conclude with a bit of a summary of that so that the people that weren't able to get there is still involved in this discussion, because we really do want it to be a collaborative session. We hosted a full-day workshop of this, had manufacturers, machinery manufacturers, just lots of consultants, as well as installation contractors. And that was, again, just highlights the urgent need for collaboration and the shared value and connection between the holistic approach of the recovery of the glazing industry and the materials within it. So the second half of the workshop was split into two groups, one looking at the logistics and technology, and the other looking at the business case and commercial viability. So as you can see, there's lots of sticky notes. I like colours, apparently. So group one looked at the workflow from on-site analysis, transport, and then separate streams for both reuse and culletization. Group two focused on the complexity of the material value, both current and in future, as well as supply security. And what was really interesting about those two groups is that when we came together, there was actually some similarities. So when we looked at the location, both of them thought there was two methods, both mobile and also a network of factories that were needed, and that they wanted the proximity near processes as well as the refurbishment site themselves. They also had to have using existing infrastructure. Unit size, again, it was sort of common sizes that were the most useful, so the 80-20 rule, how can we get the most glass in there, and that it would be limited by the transport availabilities. And then for the technology, the next steps were to have sorting technology to highlight those streams of reuse and cullet, as well as looking at technology to remove all of these separate elements together. And then for the business case, the next steps were to map future material supply and demand, define values of recovered material, as well as influence on policy, financial incentives, and carbon credits. So what I would like to say is that we really want you to come find us after this, and it's been a great workshop, and we had some great conversations with that, and let's carry on the conversation in the next 2 days. Oh, that's the wrong way. Thanks.